Hi all. In module 1, you have learnt about combinational circuits. So we all know that a digital circuit is of two types. One is combinational circuit, another one is sequential circuit. I hope everyone have started learning about sequential circuit. Okay. So in this video, I will give you the introduction to sequential circuit, and we'll be discussing about synchronous sequential circuits, types of memory elements, shift registers, and at last I will discuss about the analysis part of synchronous sequential circuit. Definition for a sequential circuit is a circuit which output depends upon present input and past output, then it is called as sequential circuit, and it will have a memory element and it will have a feedback path. Types of sequential circuits are synchronous sequential circuit and asynchronous sequential circuit. So this is the block diagram where this sequential circuit will have a memory element to store the past outputs for further process. So memory elements, what are the different memory elements used in a synchronous sequential circuit? Is flip-flop and latch. Flip-flop and latch are the two memory elements. Flip-flop is a basic building block of a synchronous sequential circuit. So it is also known as bistable multivibrator, and it is a type of circuit that can store and recall a single bit of information. Its names come from its ability to flip or flop between the two stable states. And latch is an electronic device which changes its output immediately based on the applied input. So either it will be a 1 or 0. This latch consists of two inputs, one is set or reset, and two outputs. Next is types of triggering. We have two types of triggerings, edge triggered and level triggered. Flip-flops are edge triggered and latches are level triggered. In level triggering, the latch responds to the inputs and updates its output state when the clock pulse is in either high level or low level. Whereas in a flip-flop is triggered to update its output state on the rising or falling edge of the clock pulse. So this type is called as an edge triggering method. If flip-flop is triggered when the clock pulse goes from low to high, then it is called positive edge triggering method. And if the flip-flop is triggered to update its output from high to low, then it is called negative edge triggering. So this is a square pulse which indicates the triggering method. Next is type of flip-flop. We have four different types of flip-flops. SR flip-flop, that is set to reset flip-flop. JK flip-flop, master slave flip-flop. It is also called as master slave flip-flop. Next is T flip-flop, that is toggle flip-flop. Next one is D flip-flop, that is delay flip-flop. Now we will discuss about SR flip-flops. Below these diagrams, or these are called as symbols of flip-flops. These are called as symbols of flip-flops. Next is, so what is SR flip-flop? It is a flip-flop with two inputs. One is S and another one is R. So S stands for set and R stands for reset. So here, this SR flip-flop is constructed with 4 NAND gate or 4 NOR gates. So here I have displayed the circuit diagram of SR flip-flop, where here 4 NAND gates are used, and this Q is the output. Q and Q complement are the outputs. and this one is the truth table. So S, R, these two are inputs. We are going to give a clock pulse. If 0, 0 is given in the circuit, so after the process, the output will be 0 for Q, and Q complement will be complement of Q. By substituting the value and by assuming the past value as 0 or 1, depending upon the assumption, the output of next state will be displayed. This is the characteristic table. As I said before, the S and R are the inputs and Qn is the present state, Qn plus 1 is the next state. Here we are going to consider S and R as 0, 0 and present state as 0. With this input, we are going to substitute in the circuit diagram and we will be getting the next state as 0. And keeping S and R as 0, again, we will be considering the present state as 1. Before we have considered as 0, now we will consider it as 1 and we will be workouting in that circuit and the corresponding output will be 1 for Qn plus 1, that is next state. So from this conclusion, you can tell that whatever the Qn value, that is present state, is, if the flip-flops input is 0, 0, then output will be present state. If SR flip-flops input is 0 and 1, the output will be 0, that is reset condition. It work in reset condition. If S and R are in S for S and R, if the inputs are 1 and 0, then the output will be 1, that is it will work in set condition. If both the input is 1, then the Qn plus 1 will be, next state will be 1 and also the complement of that also is 1, so which is an invalid one. So because of this we have moved to next flip-flop method, that is called JK flip-flop. So here from the characteristic table we have taken a K map for S, R and Qn. After grouping, the characteristic equation will be Qn plus 1 is equal to S plus Qn R complement. So this is about SR flip-flop. And JK flip-flop, due to the undefinite state in SR flip-flops, another flip-flop is required in electronics. So the JK flip-flop is an important or improvement on the SR flip-flop, where S is equal to R is equal to 1 is not a problem in JK flip-flop. Next is D flip-flop. It is also called as delay flip-flop. D flip-flop is a better alternative that is very popular with the digital electronics. They are commonly used for counters and shift registers and also in input synchronization. As D flip-flop is like JK flip-flop. These are basically single input versions of JK flip-flops. Both D and T are single input versions of JK flip-flops, and this modified form of JK flip-flop is obtained by connecting inputs J and K together. It has only one input along with the clock input. Next we will see about the shift registers. Shift registers, it consists of group of flip-flops. Register is nothing but it is used to store the binary data, where it is made up of flip-flops and each flip-flop will store only one bit. If suppose we need to design a 4-bit shift register, then in that condition we need 4 flip-flops for the designing purpose. And to store n bit binary data, we require n flip-flops. The main function of this shift register is to store the data and it can able to move the data. Modes of shift registers, that it will work in two different modes, left shift, right shift. It will shift the data from left to right and right to left. These are the types of shift registers. It have 4 types. One is serial in and serial out. Another one is serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Here I have given you the circuit diagram for serial in, serial out shift register. In this block diagram, serial input and serial out shift register in the has D0, D1, D2, D3 or data inputs. Okay, then Q0, Q1, Q2, Q3 or data outs. These are inputs. These are inputs, and Q0, Q1, Q2, Q3 or data output. Here we are applying single clock pulse to all flip-flops. Here we are going to apply single clock pulse to all flip-flops to make all flip-flops simultaneously on and off. And this shift register is used to store 4-bit binary data, that is from 000 to 1111. That is from 0 to 15. We can able to store the data using these 4 flip-flops. We are in this method we are going to shift the binary data from right to left. So this flip-flops can also be used in designing the counters also. So here serially we are going to give the inputs and we are going to collect the outputs in serial manner. So this is called as an serial in, serial out shift register. Next is serial in, parallel out shift register. Here serial input is given in serial way. Output is seen in an parallel way, parallel outputs. So here we can take the outputs. For every input we can able to see the outputs. Next is parallel and parallel out shift register. We are going to give a common clock pulse to all the flip-flops. Parallel input is given, that is simultaneously we are going to give inputs to all the flip-flops and simultaneously we are going to take the outputs from all flip-flops. Next is parallel in, serial out shift register. This is the diagram for parallel in, serial out shift register. In all type of shift registers, we have used D flip-flop as the type of flip-flops. Next we will see about the analysis part of synchronous sequential circuit. These are the steps to be followed in analyzing the synchronous sequential circuit. First we will be determining the input and output of the circuit from the given state equation or from the state diagram, from the circuit diagram. We will collect the input and output of the circuit and we will frame the expression. From that we will determine the inputs and outputs of the flip-flops. After determining that, we will construct the state diagram, state table, output table, all those things. So that is what. Here, what a state diagram is. State diagrams are used to give an abstract description of the behavior of a system, and this behavior is analyzed and represented by a series of events that can occur in one or more possible states.